In this lesson, you will learn how to name, bisect, and describe angles, and then we will use these relationships between angles to set up and solve problems with algebraic expressions. So we need to review a couple of angle vocabulary words that you may have heard before. The first one is how to classify an angle. So when we say classify, it's not a particular angle, but we say in general an angle that measures 180 degrees, that's an angle with opposite rays like this, that angle is called a straight angle. And this angle measure is 180 degrees. We say that an angle that measures 90 degrees is called a right angle. And if you remember the other day, when we talked about perpendicular lines, we said they met at a right angle or a 90-degree angle, and this is the symbol for that. When we have an angle that measures between 90 and 180 degrees, we call that an obtuse angle. So one ray goes more than 90 but less than 180 degrees from the other, and that angle is an obtuse angle. And then the final one that we will talk about is between 0 and 90, and an angle between 0 and 90 degrees is called an acute angle. So we now know that if we're classifying an angle, we will classify it as straight if it's 180, right if it's 90, obtuse if it's between 90 and 180, and acute if it's between 0 and 90. The next word we're going to talk about is the word bisector, and we will review what congruent means in the context of angles. So we have Johanna cut a 36-degree angle into two something 18-degree angles. So I'm just going to draw myself a little sketch here. A 36-degree angle, approximately. I'm just sketching it so I can say that's 36 degrees. And it says that Johanna cut it into two 18-degree angles. So I'm going to cut it right through the middle here. And then I have an 18-degree angle here and an 18-degree angle here. And since they're both 18 degrees, that means they have the same measure and they're the same shape. So we use the word congruent to describe their relationship. So those two 18-degree angles are congruent because they have the same measure. The ray that I drew that cuts that angle in half is called a bisector or an angle bisector. The next thing we need to do when we talk about angles is to be able to name specific angles. So again, when we classify means that we are going to classify it using one of these four words: straight, right, obtuse, or acute. And now we'll talk about naming specific angles. So when I name an angle, I have three choices. Often I can only use one of the choices, but there are three possibilities. First, I can name an angle using three letters. When I use the three letters, I'll have first letter, second letter, third letter with an angle symbol in front. And what's important is that the middle letter is the vertex of the angle. That's where the two rays intersect. So in our first example here, A is the vertex of angle BAC, or I can call it angle CAB. But A, the vertex, must be in the middle. So the first way I can name this is angle BAC, or I can name it angle CAB. Again, that vertex is in the middle, right here. The second way I can name an angle is using a number. And if I have that number in the center or inside the angle, I can call this angle 1. So I could call it angle 1. And then I have one situation where sometimes I can just name an angle using its vertex. And this is a special situation because you can only do this if it is the vertex of that angle only. So as you can see in this first example, this vertex A is the vertex only of this angle BAC, this angle 1. So I can call this angle A. In our second example here, I have angle SRP, which can also be called angle 1. I have angle PRQ or QRP, which I could also call angle 2. And then I have angle TRQ or QRT that I can also call angle 3. And this is super important. You cannot use angle R here because R is the vertex of more than one angle. So because that's ambiguous, we don't know which angle we're talking about there, we absolutely cannot call any angle in that diagram angle R. So in this final example, draw an angle that could be angle DEF or angle FED or angle 5, but we cannot call it angle E. Right? So the only reason why we would not be able to call it angle E is if E were the vertex of more than one angle. So pause the video, see if you can draw a quick example for yourself about that would meet all of these conditions. And then when you unpause the video, I'll have an example drawn that might be similar to yours. The most important thing there would be that E is the vertex of more than one angle. So you'll see in my example, I have this angle right here. This is angle DEF or angle FED or angle 5, but it is not angle E. And the last thing we want to be able to do from this video is use all of these rules about angle relationships to set up and solve problems. Anytime we do a problem like this, we're going to go through a series of steps. My first step is going to be to label the diagram. So to label the diagram, I need to go through all of the given information. So the first thing I'm told is that EG and EO are opposite rays. Remember, opposite rays would form a straight angle here. So that means I know that angle GEO is 180 degrees, which I can actually assume from the diagram. Since GO is a straight line and E is between G and O, I know that angle GEO is 180 degrees. So I'm just going to mark that into my diagram. Next, it says that EM bisects angle TEO. So I'm just going to highlight angle TEO to help me figure out what I'm bisecting. So TEO has a vertex at E. This is angle TEO here. And it says that EM, ray EM, bisects TEO. So I am going to highlight that. And because it's bisecting, I know that it cuts it into two congruent angles. So I'm going to mark those two angles congruent using these little angle congruence marks. So I know that those two angles are the same measure. They are congruent. And then finally, I have two angle measurements given. So we have this notation here. The measure of, when I see that little M there, it means measure of. The measure of angle GET, that's this angle here. This angle here measures 3x plus 50 degrees. And angle MEO, that's this one here, MEO measures 2x minus 5 degrees. So my suggestion would be that you take a minute, see if there's anything else you can fill in this diagram before we move on and try to set up an equation. Okay, so hopefully you paused the video and you may have noticed this very helpful bit of information. Because these two angles are congruent, that means that they have the same measure. So I have 2x minus 5 here, and I know this is the same, so I'm also going to put 2x minus 5 here. And now I have a set of three angles, and three angles all together add up to the total of 180 degrees. So when I add these three pieces of angle together, 2x minus 5, 2x minus 5, and 3x plus 50, I must get this 180 degrees. So my second step is to set up an equation. So now I know that 3x plus 50, that's that first angle, plus 2x minus 5, my second angle, plus another 2x minus 5, my third angle, has to equal the total of 180 degrees. So now I'm just going to group my like terms together. 3x, 2x, and 2x gives me 7x. I'm going to group my numbers. 50 minus 5 gives me a positive 40. And on the other side, I still have 180. I'm going to subtract 40 from both sides. So I get 7x equals 140. And then I'm going to divide each side by 7. So I get x equals 20. And now I am going to go back in and make sure that this makes my geometry correct. So in algebra, we just need to make sure we solved correctly, but we need to make sure that all of our angles have positive measure. So we're always going to go back and plug into the diagram. So I'm going to go back into the diagram with my x equals 20. 3 times 20 is 60. Plus 50 is 110 degrees. 2 times 20 is 40 minus 5 is 35 degrees. And again, 2 times 20 minus 5 is 35 degrees. 35 and 35, those are the same, so I get my congruent angles. 35, 35, and 110. 110 plus 35 plus 35, that's 70. So that adds up to 180, which was my second condition. So now I feel confident that I have found the value of x. And the last thing I'm asked to do is find the measure of angle GEM. So GEM is this whole angle here, GEM. So that means I'm going to add up this blue angle and the yellow angle. So I need to add up 110 plus one of the 35s gives me 145 degrees for my measure of angle GEM. And now I have set up and solved an equation. So let's just go back and make sure that we have hit all of our objectives today. So we named angles using 3 letters, one number or one letter. We learned how to bisect or cut in half angles and how to use congruent symbols to mark it. And we learned how to classify and describe these angles using relationships. And we also set up and solve problems using those relationships. So now you're ready to get some practice. Don't forget that when we are talking about classify, we mean acute, right, obtuse, or straight. And when we talk about naming, that's when we are talking about those letters.